I'll start with a brief introduction. And then Dr. Bagler will speak. Dr. Ganesh Bagler is going to talk on computational gastronomy, making food computable, because the world is changing. He is a professor at Infosys Center for Artificial Intelligence in the Presta Institute of Information Technology, Delhi, in New Delhi. Professor Bagler is known for the pioneering research in computational gastronomy, the emerging data science that blends food with artificial intelligence. Trailblazing research from his lab has established foundations of this niche area that deals with food, flavor, nutrition, and health. Professor Bagler has an audacious dream of transforming the global food landscape through data-driven innovations. When I heard him a couple of months back, it was very surprising that he has created a new field. In the modern times, it is almost impossible to create a new word, forget about new field, and he created a new field, computational gastronomy. Let's listen to him today and see, not only for curiosity, but also to improve our health. Dr. Ganesh Bagler, please start.
Thank you, Dr. Rao, and a very good morning to all of you at India Home, and a good evening from India. So what I intend to do is to give you a glimpse of this new area of computational gastronomy, wherein we are trying to look at food from a completely different perspective. And I know that most of you would be interested in food from the context of culture, flavor, nutrition, and health. So let me see how much I can touch upon all of these aspects as I go along and tell you about what we are up to as part of this new endeavor called computational gastronomy. So I'm Ganesh Bagler. I'm from IIIT Delhi, and we are completely focused on various areas in computer science and related disciplines, which includes computational gastronomy, wherein basically we're trying to look at food from a data-centric perspective, from an informatics-centric perspective. So I'm part of this Infosys Center for Artificial Intelligence, wherein we are trying to use the tools of artificial intelligence, which many of you may have heard about. So as I go along, I'll explain what it means. So this is a new area, artificial intelligence, wherein we are trying to mimic intelligence of a human into a computer, whether it is artistic endeavors such as painting, music, poetry, literature, and to an extent even cooking. Can we possibly imitate these intuitional abilities of humans into a computer such that we can make our lives better? Well, that's a question we are asking in my lab. So many of you, if you think, since I'll be talking about food, if you think that I must be a foodie or somebody who has been interested in food for a long time, you would be getting it wrong absolutely. So I have been rather agnostic about food for a long period of time. In fact, as a teenager, I always wanted to be an astronomer and, be under the sky, look at stars, constellations, and try to discover new stars if possible. But I never could do that, despite the fact that I did my master's in physics and followed by another master of technology in computer science. And then I moved into the domain of biology, wherein we tried to use the tools of computation and physics and mathematics for understanding biological phenomena, whether it is a disease, a complex disease such as cancer, asthma, diabetes, or for that matter, looking at interesting drugs that come from Himalayan medicinal plants. So I was briefly in Himalaya after returning from my postdoctoral stint at Berlin, Germany, at Max Planck Institute of Molecular Genetics. to be able to do some interesting work in the area of drug discovery. And when I was an assistant professor at IIT Jodhpur, it happened wherein I serendipitously ended up looking at food from a data-centric perspective, basically recipes, Indian recipes from a data-centric perspective, and the rest is history. We have ended up creating a new area which is now being appreciated all over the world, both in academia as well as in industry. So my lab has been doing this work for the last 6 to 7 years, and we are considered to be the ground zero of computational gastronomy. So let me elaborate on what are we trying to do in the context of food. And of course, I know most of you would be wondering, what has food got to do with computer science or computing or data? Because food and cooking is a magical phenomena, something which is intuitional, it's an art, it's an artistic endeavor. And that's how most of us are looking at food and cooking all the time in our lives. And that's how, in fact, I was also imbibed into looking at food from an artistic perspective. Interestingly, if you look at recipes that have been passed on from generations, which all of us are, addicted to, accustomed to eating, you would realize that these recipes have taken of the order of centuries, if not more, to come to their present state. And incidentally, these recipes are nothing but combination of raw ingredients in an idiosyncratic manner and processing them in a very special way to be able to come up with these delicious recipes that we are all familiar with, whether it is dal makhni or paneer butter masala or any other recipe. It could be dosa, paratha, or idli, or any other recipe that you can think about. All of these are nothing but very special ways of putting raw ingredients together to be able to create a delicious outcome out of it. So this magical process of cooking, incidentally, has been at the core of disproportionately increase of brain sizes that we human beings, as they are known as Homo sapiens in a scientific parlance, we have got these disproportionately large brain sizes. And it has been argued that incidentally, the ability of cooking provided enough time for us to stop exploring food and thereby giving enough time for us, thanks to the cooked and delicious food that was available to us, giving us more nutrition than what a raw ingredients can provide. Thereby, over time, it has allowed us to increase the brain size to an extent that it has been argued that cooking, apart from complex languages that we tend to have, is one of the most unique things that we have. And that is something which defines us to be human. And I'm sure all of you would agree that no other species, no other animal on the face of the earth has got the kind of special dietary practices that we have, cooking practices that we have, as elaborate as human beings tend to have. And this is the argument which has been made by Richard Wrangham in his book called Catching Fire: How Cooking Made Us Human. Well, over time, as most of you would have heard about, that the science says that we have evolved from being a very primitive species for the last so many millions of years to becoming what we are today, the most dominant species on the face of the earth. But incidentally, it looks like in the last less than a century, in fact, half a century, may I say, we are being plagued with the epidemic of lifestyle disorders, such as obesity, type 2 diabetes, cardiovascular disorders, and some forms of cancer, which are evidently diet linked. And if you try to figure out what are the various factors that go into that can be attributed towards this rise of lifestyle disorders, then many of you would have heard about that. Of course, genes play a role to some extent. The ambience, social ambience plays some role. And of course, not to mention our lifestyle, sedentary lifestyle or activity that we indulge into also plays a role. But of all the things, most of these lifestyle disorders are strongly linked with the kind of diet that we tend to have, apart from the exercise that we end up doing. Well, given such an important role of diet in these diseases which eventually most of us are getting plagued with. Question is, how do we deal with food, and can we look at it from an intelligent fashion and try to understand the cultural facets, the flavor aspect, the nutrition aspect, and the health aspect of it. So that even for that matter, we are going to have 10 billion people very soon by the year 2050. So how are we going to feed these 10 billion people by using the traditional practices of agriculture, as it is called, from farm to fork? Can we revolutionize the food practices so as to be able to come up with technologies which can help us making the humanity healthier, and apart from making them, feeding them so as to take away the hunger? Now, this is where I would like to bring in the aspect of computer science, the data. As you may have realized that over the last couple of decades, different aspects of our life have got revolutionized by the introduction of data, whether it is, the railway reservation system, face recognition, logging into MacBook, to tagging into Facebook. Everything seems to be, critically indulging into data-driven analysis. And also the Google Maps, the Ubers and the Olas, and many other aspects of our lives are getting transformed dramatically by the introduction of data and ability to churn the data using computational techniques. So the question is, can we understand food and different aspects of food from a data-centric perspective? That's what I consider to be making food computable. Finding different aspects of food and trying to convert them into a completely digital domain, analyzing them, coming up with inferences which can help us eating healthy food as well as tasty food. Can we do that? Well, when we started looking at it, we realized that food has got multiple dimensions, of which the most critical one are the recipes that we tend to use and eat on a day-to-day basis. And these recipes are coming through traditional practices and have been passed on from generations. So can we understand the composition of these recipes in terms of which ingredients we tend to put together to be able to come up with delicious recipes, and some of the rules that have gone into these practices? Some of you may have heard about something called Viruddhahara, in terms of putting certain ingredients together and some incompatible ingredients which should not be put together. So have they shaped the recipe structure, architecture, to be able to come up with the present day architecture of the cuisines? Well, that's one of the dimensions. Of course, the food that we eat and the ingredients that we tend to use in our recipes are also heavily determined by the flavor that they have. The pungency of the onions, or the sweetness and the savoriness of mangoes, and think about any other ingredient for that matter, whether it is a vegetable, herb and spice, or lentils, etc. All of them have been practically been chosen by virtue of their flavors. And of course, the nutrition, the kind of nutritional value that a food ingredient provides to us, such as the macronutrients as well as the micronutrients in terms of vitamins, minerals, and in terms of macronutrients, the calories, the fat, etc. All of these need to be considered. And finally, the health impact. We know that ingredients tend to have different kind of health impact in terms of producing certain diseases, or in fact helping us from getting into such disease conditions as well. And there is a lot of literature, scientific literature available about this. Can we digitize all of this wealth of information and do some data-centric analysis to be able to produce inferences which can be useful? And that's the question we have been asking. And with this effort, we have ended up creating this new niche, a domain completely, called computational gastronomy. And I'm proud to announce, sitting in India, to all of you who are associated with Indian subcontinent or related region in one way or the other, that all of this new thing has started very well within India and has been propagated heavily into various different parts of countries, a different part of the world, including Europe and America. So computational gastronomy, in summary, is a data science which puts together food, data, and the power of computation for achieving data-driven food innovations. So what are these innovations that we are talking about here? I'll be explaining those to you in a brief manner. To give you a small bit of history, we started working on this project, a very small project, when I was still at IIT Jodhpur, wherein we realized that India is a potpourri of cultures having rich and diverse culinary heritage, which I'm sure most of you would agree with. Given that, can we look at various cuisines and the recipes that are coming from different parts of parts of India, and understand its combinations of ingredients that go into different parts, such as Maharashtrian cuisine, Andhra cuisine, Tamilian cuisine, Telugu cuisine, or West Bengal cuisine. Can we look at those from a data-centric perspective? That's the question we were asking. And while doing so, we compiled a large number of recipes, 2,543 recipes, primarily coming from a data repository of Tarla Dalal, which many of you would have heard about. And we started looking at ingredients that go into the recipes, and further, the actual flavor molecules that are present in these ingredients, whether it is potato, tomato, chili, tamarind, asafoetida, the hing, or any other ingredient that goes into the recipes. We compiled this meticulously and did an analysis, which I'm not going into deep because that's not the agenda of today's presentation talk. We looked at what is called as the food pairing pattern in terms of what ingredients typically tend to be used together vis-a-vis the other ingredients which are not used together. And by doing this, we ended up finding out what is called as the culinary fingerprint of cuisines. This is very similar to the DNA fingerprint that you may have heard about, wherein a DNA fingerprint uniquely identifies a given individual. Exactly in a similar manner, we treated a cuisine is like a cultural identity which has got idiosyncratic practices which have been gathered over centuries, if not more, millennia, by thereby putting together certain ingredient combinations in a very, very idiosyncratic manner. And that's how we ended up defining the culinary fingerprint of a Punjabi cuisine or Maharashtrian or Oriya cuisine, etc. We did that work way back in 2015 and identified that Indian cuisine is rather unique in terms of the way it puts together the ingredients and is in fact very, very different from those of the Western cuisines. When I say Western, I'm referring to largely the North American, Latin American, Southern and Western European cuisines predominantly. And we also ended up discovering in this research article we published in 2015 that spice tends to be the most critical aspect of Indian recipes, the exact placement of spice. What kind of a spice is actually used in a given recipe is very, very unique and it can't be replaced with other spices as well. If you do so, you will end up disturbing the rubric of Indian recipe and therefore the structure of the Indian cuisine would be disturbed. And that's why we ended up calling this as a critical observation and declaring spice to be the taste of India. And most of you wouldn't be surprised. In fact, Indians are never surprised when they are told that, in fact, mathematics and computer science based study of Indian cuisine is telling us that spices are key contributors of Indian cuisine. Of course, we know that. But the beauty of this work is that what was otherwise known to be an intuitional fact was ascertained by using a rigorous mathematical analysis of Indian cuisine. And this research was highlighted by none other than MIT Technology Review as the emerging technology and was highlighted as best of 2015 way back. When this research came to the fore, it became extremely popular and was highlighted in more than 200 different media outlets, including New York Times, Washington Times, and in India, Times of India, Hindu, and a variety of magazines and media outlets. Veer Sanghvi, if you know him by any chance, who publishes a regular article called Rude Food in Hindustan Times every Sunday, wrote about our research in the title of The Magic of Indian Spices. And now this particular article is part of the book which is published called The Indian Pantry. And of course, a variety of magazines and news outlets highlighted this work, telling us how Indian cuisine is unique and how spices play a key role in those. Going further, chefs, the practitioners of cooking themselves were impressed, and this Michelin star chef, Chef Garima Arora, ended up using our science for playing with the recipes in her kitchen, in her restaurant called the Ga in Bangkok. And this was written as a decoding of flavors in one of the Dubai-based newspaper. And Royal Society of Chemistry, UK, Chemistry World magazine put it on the cover of the magazine in the article called Currying Flavor. And industry was not far behind, importantly. Despite the fact that I had been working in academia for a long period of time and have been doing some interesting work in the area of network biology and in silico drug discovery, none of my research ended up becoming important in terms of getting industry traction. And this particular work, which I had taken up serendipitously, became extremely important and was considered to be the sweet spot of food industry. Over the period, a large number of food companies, whether they are based in India or outside India, multinational companies as well, have ended up taking up this science extremely seriously, given the fact that we are the pioneers in trying to bring together data and food. Well, having told you about this historical tidbit very briefly, now let me tell you about what is the futuristic perspective here and how are we going to change the world dramatically by using these data-driven food innovations, by making food computable. What are we trying to do here? And let me explain that in a brief manner. We are trying to use data-driven food innovations in the context of, first of all, the recipe architecture itself. How do you understand recipes and cuisines? And can we change recipes in a manner to be able to make them tastier and healthier? Can we do that? And of course, not to mention nutritious. Secondly, in the space of molecules which are central to choice of ingredients, as well as artificial flavor molecules which are being predominantly used in the processed food industry today, which is in fact becoming a problem in a big way. Can we do some revolution in that context, molecular aspects? And finally, the nutrition and health aspect. Can we understand it in a better fashion by using data-driven approach, and can we make our life better? Well, while looking at food from these angles and these questions, we realize that to be able to do anything meaningful in the context of in the domain of food, we need to have well quality curated data, structured data. If you do not have enough number of images, pictures that you load on Facebook, then Facebook won't be able to recognize you as an individual. Or for that matter, even a computer, unless it understands various aspects of your face, a Mac, for example, a MacBook would not be able to let you to log in into the machine by looking at your face. Exactly in a similar manner, unless we understand food ingredients, natural ingredients which go into the recipes, and the flavor molecules, the molecular basis, etc., from a data-centric perspective, unless we collect these databases, we won't be able to do any kind of analytics around it. So we started collecting these data of recipes under the name of RecipeDB and FlavorDB, just to give a couple of examples to you. RecipeDB is a structured compilation of recipes from across the world, including that of Indian subcontinent. So we have more than 118,000 recipes which are available online for everybody to explore, and it is published in a scientific magazine, journal. These are coming from 24 world regions and 26 world regions and 84 countries. Herein, you can actually search for a recipe. For example, show me a Mexican recipe which is having tomato but doesn't have onion, for example. If it should not have calorie, the amount of calories should be less than, say, 800 kilocalories. If you ask that question, it will be able to churn out a recipe and provide it to you on the platter. Exactly in a similar manner, we have created a database of flavor molecules, wherein for each of the ingredients that goes into the recipes, whether it is a dairy, fish, bakery, meat, herb, lentil, or for that matter, any other food type, ingredient type, there are 26 to 28 ingredient types that we have categorized. For each of them, around 1,000 ingredients, we have provided an exhaustive list of flavor molecules that are naturally found in them, and thereby allowing you to do what is called as a food pairing. If you want to find out which ingredients would end up going well together with each other by virtue of something called food pairing hypothesis, I can answer this if you have any questions later on. FlavorDB allows you to explore that. Well, where are we taking all of this data? What kind of direction we are moving into? So one of the thing that we did after investigating Indian cuisine is to go beyond India and look at the world cuisines. And in this analysis, we have taken more than 1,45,000 recipes from across the world and have created or found out their culinary fingerprints, which allow us to identify how Indian cuisine, for that matter, is different from that of a French or a Brazilian or an Italian cuisine, for that matter. So we can identify the uniqueness of Indian recipes, just to give an example, vis-a-vis the other cuisines in terms of what kind of ingredients tend to be used more, which ingredient categories are used more, and what ingredient combinations tend to be dictating these recipes. By doing this, we also have created like language tree, which tells us how the Indo-Arabian languages they fall in a single branch, which further get bifurcated into the North Indian languages, for example, and other languages are in a different branch completely. Like you must have seen this language tree. In a similar manner, we have been able to create what is called as the world cuisine tree, which tells us how cuisines are related or different from each other when you look at cuisine and try to compare one with other by using the culinary fingerprint. And all of this work is giving us some perspective into how cuisines may have evolved over last couple of millennia, if not more. And notice that starting from the agricultural revolution, roughly 13 to 15,000 years back, we have ended up creating richer and more complex cuisines over time. And this tree gives us an insight into this process, evolutionary process. Why are we asking this question? In a more applied sense, we are asking this because we want to figure out what is the actual number of recipes that theoretically can be created, given that there are 1,000 type of ingredients that are available to us today across the cuisines in the world. Well, turns out that given that a typical recipe has 10 ingredients, we have done the statistics and we have the data for that. 1,000 ingredients can be put together in a permutation and combination manner to create 10 to the power 30 number of recipes, which is a huge number. This is a number which is more than the total number of stars that are estimated to be there in the whole universe. Well, that's exorbitantly large. Therefore, can we come up with new recipes which have been not part of cultures and traditions and cuisines across the world? Well, that's the question we are trying to ask. Humanly, it is impossible to come up with all kinds of combinations, but computers can be helped and computing can be used in the context of putting together these ingredients to design new recipes. I don't know how many of you have seen this movie called Ratatouille. It's an exploration, adventure of a rat into the culinary space of human beings, wherein it is trying to eat better and delicious food, the rat. And while doing so, it ends up creating new recipes in the process. Well, in this movie, Chef Gustav keeps saying this repeatedly, that anyone can cook. And therefore, we are asking this question about, can computers cook? Can they help us design new recipes like a grandmother or a mother can do, a chef can do, a culinary enthusiast can do? Can we capture the intuition of a human into a computing program? And incidentally, for the last couple of decades, a lot of interesting things are happening wherein computers are trying to imitate the creativity of a Picasso, a Mozart, or a Beethoven, or for that matter, A.R. Rahman, into a program, trying to generate new music, new art, new literature. Now, that might sound a little dehumanizing, but at the same time, the idea is not to dehumanize, to take away the creativity from the humans, but rather to enable a chef into thinking creatively and come up with new recipes. And in that direction, we have created this tool, Ratatouille, which is available freely online, where you can actually use the deep learning artificial intelligence power to generate a new recipe. You can choose a set of ingredients from the one which are flashed in front of you, like in this picture. You can click on certain ingredients and ask our supercomputer, which we have at IIIT Delhi, to generate a new recipe. And you will end up getting a recipe such as this, which starts from a simple instruction such as, in a large soup pot, season your chicken, etc., all the way up to how to serve it and garnish it. And this seems like, very, very, surprising for many of us, because we are not used to computational creativity. But that's what Ratatouille is trying to do. And we hope to create new recipes in this process, get them vetted by chefs, to an extent even nutritionists, to come up with absolutely new things which are tasty and healthy. And FlavorDB is also available. I had mentioned about it earlier in terms of exploration. And this is the URL which is available at the bottom of the slide, which can be used to explore this database. Can diabetes be cured, or can be helped taking care of the problem of diabetes, which partly can be done by creating new sweeteners which are not adding to the calorific value, at the same time giving you the same sweetness that you are used to. And we are doing that at the molecular level by creating this artificial intelligence or machine learning algorithms, which will take a molecule, and there is no dearth of small molecules. We have of the order of a few billion molecules that are available in a database called PubChem, which can be used to make prediction. The algorithm can then be used to make prediction about bitter and sweet molecules. Again, this is a published work and is available on this URL at the bottom. You can explore it if you wish by drawing a molecule, those of you who are a little more chemically oriented, and by figuring out what taste it might have. The agenda here is to come up with artificial sweeteners which are nature-like and hopefully can help us curing diabetes. The last dimension that I'm going to touch upon in today's talk is that of the dietary interventions that can be created using computers. All of us are fed up with these assertions about how, for example, egg is good or bad for you, wine is good, or for that matter, bad for you, or fat is good and bad for you. All of these assertions, which we read in newspapers typically, are coming from scientific literature. Why is it that science and scientists are coming up with these contradictory assertions about certain thing being good or bad for you? Well, partly because it's like an elephant and a blind man problem. It's a very, very complex entity, the human body as well as the food. And the way food interacts with human body, giving rise to health consequences, is not as simple as a mathematical equation that I've put in front of you. Therefore, it's difficult to understand. That is why we are getting all these assertions which confuse us as a layman. Therefore, what we did is to dig out this scientific literature wherein a food is mentioned, a disease is mentioned, and an association between the two is mentioned in terms of they being positively linked or negatively linked. And we created this database called SpiceRx, wherein to begin with, we compiled the information of positive and negative effects of spices and herbs, which we use in culinary preparations, and molecules which go into these ingredients, such as ginger, garlic, or other spice and culinary spice ingredients. And by this, we are able to come up with an idea about how culinary herbs and spices tend to have broad spectrum benevolent effects beyond their antimicrobial effects, which are very well known by now, and thereby it could be the reason why traditional culinary practices have imbibed you in using these herbs and spices in a creative fashion, despite the fact that they don't tend to have nutritional value, but they may have other values which are beneficial for health. And eventually, we have moved on in the direction of creating Diet RX, which looks at not only herbs and spices, but close to 2,200 food ingredients, which are present in recipes across the world, belonging to 28 different food categories. As I told you, fruits, lentils, alcoholic beverages, caffeinated beverages, and other categories. And wherein we have tried to come up with this repository, which has combed through more than 90,000 research articles. So 38,000 research articles coming from 90 years, last 90 years, where food and disease associations are available to us. And genetic associations and chemicals are linked by using empirical data, the available data online. All of this, we believe, can be taken in a direction where we can create recipes which are directed towards beneficial towards certain lifestyle disorders which are strong, having strong diet links, such as obesity, cardiovascular disorders, and type 2 diabetes, for example. And in this direction, we have also created this Ayurveda informatics framework, wherein we have dug into the Ayurveda literature and for the first ever time created this trademark framework, which looks at the Rasaguna Karma Virya Vipaka combination, which are attached with food ingredients and plants with their health effects, such that we can come up with new recipes which are driven by the knowledge of Ayurveda as well. I believe that all of this work that is happening in the domain of computational gastronomy will take us in a direction of personalized nutrition. Many of us, you would have come across these recommendations for those who are diabetic, may eat this or may not eat this, a generic recommendation. Science has come to a conclusion that perhaps these generic advices, which are typically given by nutritionists, are not on the right spot, because this particular landmark science published research paper that was published in 2015 showed that the same diet, same breakfast, which is consumed by around 1,000 people, ended up giving a completely different blood glucose response, the postprandial glucose level, post-meal increase in glucose, suggesting that food is extremely personal. If I have diabetes, what I should consume, what food should I consume, could be very different from what you may have. I may be okay with idlis, whereas you may have to have paratha or dhokla for that matter, right? And all of this, they actually came up with dietary advices and verified that a machine learning algorithm, which is called as a personalized nutrition predictor, can be used for coming up with interesting and meaningful advices towards making personalized nutrition. To summarize, all of this that I'm telling you is essentially completely new science which is done in the context of food and data and computer science, where we are trying to use the tools of this newly found fancy tool of artificial intelligence in the context of food to come up with very, very interesting food related applications, such as food beverage pairing, where companies are trying to use interesting food beverage combinations which will taste good, making prediction of taste and odor of small molecules to come up with sweeteners, for example, which are better for our health. Culinary fingerprinting of cuisines, telling us something unique about each of the cuisine, because I know some of you may like South Indian cuisine, within that maybe Andhra cuisine better versus Tamilian, or somebody might be more accustomed to Maharashtrian cuisine for that matter. So can we understand these better to be able to come up with recipes which are healthier and tastier and still are similar to the cuisines that we like? Dietary interventions towards some of these diet-linked disorders. Food and beverages design. Remember, this has been the major bane of the processed food industry. Can we turn it on its head and come up with new food and beverages designs which are again better, at the same time tasty? And not to forget, making food sustainable. can we keep on innovating in a manner with the help of data and computing such that food can be sustainable as we move into a future where we need to feed 10 billion people? Well, this is my journey of last 7 years, wherein we have embarked on this journey of transforming the global food landscape. And this experience, this journey, I'm trying to put it together, pen down as a popular article, science book with the name Bite, the Digital Science of Food, which should be available to most of you who may enjoy this journey and to see what future has laid out for us with this new tool of computational gastronomy. To end my talk, I would like to present this quote by none other than Brille Savarin, the person who wrote this book called Physiology of Taste roughly 150 years back and coined the term gastronomy in the first place. It has taken us close to 1.5 centuries to reach from gastronomy to computational gastronomy. However, what he said way back, Brille Savarin said way back, still rings true. The discovery of a new dish confers more happiness on humanity than the discovery of a new star. So while I have not been on the path of being an astronomer and astrophysicist to discover new stars, but I think with the help of a lot of other people who are embarking on this journey of computational gastronomy, I should be able to discover new dishes to make humanity happier and hopefully healthier. That's what I'm trying to do. So thank you for listening to me patiently, and I'm available for any questions that you may have now. Thank you. Questions, queries, critique for some of the ideas that I have presented, anything is welcome.
Dr. Bagler, this is Kishan from New York City.
Namaskar.
Namaskar. Thank you very much, Dr. Ganesh Bagler. It was nice hearing and listening to you. It's also, just like you say, it's computing gastronomy. It's like a power of Zoom, because there's a reason we are able to connect with each other all the way from India and around the world. And because of you and Dr. Rao, and because of India Home, we are learning and getting all the knowledge and information, people like you coming over on India Home platform. And Dr. Bagler's people like you possess so much knowledge and education and experience and training that we wish you a lot of bright future and advancement. And we are proud that one of our brother is such a level that we have a hope that even India's future is a much bright because of the scientists and like you and other people. I see also your book you're coming out with, Bite. Name is itself is very, very interesting, and wish you all the success.
Thank you, sir. Thanks a lot. Thank you. Thanks for your kind words. I really appreciate that. Yeah.
You're welcome. At the same time token, I would like to say a few words for Dr. Rao, who has been coming on our India Home platform week after week after week, in and out, and I always forget to mention him. And he has been like a pioneer, bringing in all the scientists and philosophers and writers and authors from all corner of the world. And God bless him. I don't know how and where he finds all those people that it helps and guide us and gives us a healthy and nutrition information. God bless him, and a lot of best wishes to Dr. Rao also. Thank you.
Thank you, Kishan uncle. Is there anyone else?
If not, I have to say something.
Yeah, I don't see anyone raising hand or anything. Yeah, I think you can go ahead, Dr. Rao.
10 years back, no one in US also thought that we will drive cars that are electric. Even today, most of us do not think that we will sit in a car and we don't have to drive. But I have friends who are sitting in their car, driving without doing anything. And rather sometimes, if you want names, I can give Kiran Thakkar. He said, sometimes he sleeps without any worry. Not in the local traffic, but on the highway traffics. So none of these things were thought of, even by the most advanced brains or most advanced people in the field. In the same way, I'm very sure one sentence that Dr. Ganesh Bagler said, tasty and healthy can be computed. I strongly believe it, because though I'm not as advanced as he is in this subject, I have some familiarity with the subject. That's the reason why I'm trying to convince people that you can have healthy food, you can have tasty food, you can have personalized food. And I want to add one more thing later, probably after a few weeks or whenever Dr. Bagler is ready, that all this can be done without spending horribly expensive money. Today, people are spending 4 times more money than what it requires to have a healthy meal in United States. 4 times more, yet they don't have healthy food. This is also published, and I can share the paper with Dr. Bagler and others. So we are putting all these things together. Eventually, it will emerge that you will have wonderful food with taste and health. So that's my 2-minute thing with Dr. Bagler. Of course, Dr. Bagler, I will communicate all these things via email with you, because the simple comments on a meeting you and I know very well will not be sufficient for serious science work.
Indeed, indeed. And I must thank you once again, Dr. Rao, for having me on this platform. It's a very unique platform in terms of having senior people talking to them and telling about my science. I believe, hopefully, they would be able to appreciate. And if they can do it, probably anyone can do it.
This will percolate. It's not only these seniors, but those who are on the call today. And this will actually go into a Desi group from Bangladesh later. And all these people will keep talking about these to their children, grandchildren, and that's what is happening, and we have seen that. So we have 10 minutes more. I have one request to you.
Yeah.
All of us drink tea, and you have a lot of database numbers with tea and other various foods. So can you please talk about tea? How many teas are there? How many flavors are there from your database?
Right. So in my database, the flavor DB, we have a list of flavor molecules that are generically attributed to tea, not specific varieties of tea as such. We have not been able to get enough information on different type of tea varieties which are grown, say for example, in Darjeeling versus that of Palampur and versus that of in Jammu probably. We don't have that information available with us. But so incidentally, since you are asking, I have engaged in a commercial project, and I can mention that with a big multinational company, Unilever, wherein we tried to come up with interesting combinations of rather flavors of tea, tea flavors that can be added to tea, which will potentially be liked a lot by virtue of its flavor combined with the dish that or recipe that one is consuming, and hopefully it will be also healthy. And this is where we realize that, as we can imagine also, that all of us are aware of cardamom tea, ginger tea, and similar. So we have been able to come up with an interesting set of combinations, flavored teas, wherein the company is trying to sell this to begin with in the European market. So what I can tell you is that yes, a range of teas that we have explored, but unfortunately a lot of data that we created in this process has gone into a commercial endeavor. So it's not available for public consumption at the moment. However, very soon we should be able to get more information on varieties of teas and pass it on to anybody who would like to use it. You're muted, Dr. Rao.
On the tea itself, like the wine, there is a ranking, but that's not based on data or science like your subject.
Yeah.
It's purely on the taste of the people or the tasters. But can we create ranking for teas based on science, data, and your subject using computational gastronomy?
Absolutely. The answer is straightforward, yes. And one of the major problems that has been there, not only in the space of tea, but also in the space of alcoholic beverages, which we have worked with again, one of the leading giants, multinational giants in the space of alcoholic beverages, is that they keep this information of flavor composition of the products, tea versus and the alcoholic beverages, extremely secret. They just don't provide it to you in bulk. Of course, I can take some samples of these beverages and try to do my own experimentation using tools such as gas chromatography and spectroscopy to be able to find the flavor molecules. But having bulk data is something which is a problem, and all of these data being proprietary, they don't make it available to us. But to answer your question, the straightforward, yes, using science and data, we can create a ranking of both teas as well as other beverages.
So I'll summarize my tea topic with one. Why am I asking these things? Because all of us drink tea.
Yep.
I suppose that more than 1 billion cups are consumed every day, just in India. And one day it so happened, one of the Indian cities, I went to get tea in a star hotel. Even though I paid 350 rupees, I could not drink it after the first sip. So I left it, of course. The star hotels do not force you to drink it. They force you to pay, probably. Then when I came out, I told my driver that you took me for a good tea there, but the tea is not good. So let's have tea. Then he said, oh, sir, the next street there is a dabbawala we can have. So I had tea there. It is really, really wonderful. It's not even 10 rupees. I think 7 rupees or something that they take, but I take double tea, so it's 14 rupees. So as a scientist, I know for sure the tea that they served is not only not tasty, but not healthy.
Right.
Also. Whereas this tea that the street vendor gave is very good. So if with your data, if we can establish in US, in New York, that this is the tea of the year, maybe in different categories, of course, not just only one tea, then that will be a service for increasing the health of the people in the world for those who are drinking tea.
You're right about it. So it's eminently doable. All we need is, of course, some data of the teas and their flavor composition. And we do have that data, but as I told you, it was provided to us confidentially by a big giant, and obviously they don't expect us to disclose that information. But such an experiment of collecting the data, ranking them, and making it open for public consumption, it would be a wonderful exercise with a not so huge money that is required as a funding exercise, may I say. But it's eminently doable and is a laudable exercise given the fact that, as you rightly said, tea is consumed by billions of cups per day. You're right about it.
I will communicate with you directly, and
Sure.
hopefully in the next few months, we'll bring the best tea that Dr. Bagler suggests to all our India Home people.
Sure. And please, I would request those of you who are interested in experimenting with food to visit Recipe DB, Flavor DB, as well as the Ratatouille for playing around and figuring out something that you may end up liking there.
Everything is going on time. Thank you.
Yeah, send us the website so you can put it in the chat.
Yeah, sure.
Yeah.
Sure. Thank you.
Dr. Bagler, whatever sites that you want us to visit.
Yeah. So I can put it in the chat box, and I can as well email separately. Apart from that, I will do that as well. Yeah. Putting it in chat box right away. Oh, sorry. It was a mistake. Yeah. The second one is the right one. Should I? Yeah. Then you have Recipe DB. And Ratatouille. These three should be good to begin with.
And there is a movie. That Ratatouille is a movie.
Yes. Many of you, if you have not seen it, you must see it. It's a fantastic animated movie. Just getting the URL quickly. Yeah.
Dr. Bagler, is it a movie? Is quite a new one? It's a quite old movie.
It's a fairly old movie.
Fairly
I
old.
remember seeing it many years back, and
Yeah.
it is available on Netflix, I believe.
Yes,
Okay,
yes,
thank,
it is available.
thank you.
Yeah. Yeah, it's an old
Thank you,
movie.
Geeta-ji, for all the coordination.
Yeah.
Yes, thank you. Thank you. I think still he's sending the websites.
Yeah, I'm done with it. I've sent you 3
Okay, you
websites.
did? Okay, perfect. Thank you. Thank you so much, Dr. Bagler, coming to India Home and giving such a good presentation. Definitely our seniors will take advantage of this opportunity. Thank you so much. I'm good.
Yeah, thank you.